Happy Tuesday, everyone, and welcome to today's Lightbend webinar, Build Real-Time Streaming ETL Pipelines with Akka Streams, Alpakka, and Apache Kafka. My name is Oliver White, Chief Storyteller at Lightbend with a small cold today, and I'm happy to welcome back Konrad Malawski, one of our most frequent presenters on our Lightbend channel. While I introduce today's speaker and presentation, I'd like to ask our audience a quick poll question. Which of the following technologies are you currently using in production? Noting that they're all part of our integrated fast data platform. So for those of you who don't know Konrad, he's quite a well-known conference speaker, Java 1 rockstar, author, and senior engineer on the Akka team at Lightbend, where he's in charge of Akka HTTP, also part of the Reactive Streams initiative. So we're actually pretty lucky to have him with us today to discuss real-time streaming ETL pipelines and why they matter to enterprises like yours that are increasingly turning to streaming fast data applications. Probably you're joining us today because you're in a team that has been tasked with learning to build real-time streaming pipelines, which are meant to process never-ending data flows in jobs that can last for months or even years. And this is quite difficult to grok because things were, in fact, a lot easier when all of our data used to be stored offline, analyzed overnight in batches, and where the need for resilience, scalability, and responsiveness were not necessarily critical because you could react to that data later on. But now all of our data is online, in motion, and generated constantly. So for architects, developers, and their businesses, this means that there's an urgent need for tooling and applications that enable projects to move away from batch-centric processing and ETL workflows to streaming pipelines that are fully reactive. Let me close the poll. So today's webinar is made possible only by our growing list of happy subscribers, including some of the most admired brands in the world, such as Weight Watchers, who depends on Scala, Akka, and Play framework to help millions of people lead healthy lives. They're looking for some talented engineers to join their team in New York City. You can find out more about this opening, as well as other openings with our clients under the Company tab on lightbend.com. If you have any questions, feel free to add them to the GoToWebinar control panel, and we'll see if we have some time to get around to them in the Q&A part of today's session. If you are a Lightbend subscriber, you know that you have unlimited access to our expert engineering team through the customer portal, where you can ask any technical questions, what-ifs, how-tos, and advice for best practices at any time. You can also email me directly at oliver@lightbend.com, and I'll do my best to connect you with the right people. All right, that's all from me. Konrad, thanks for joining us today. Welcome.
Yeah, thank you. So let's dive right in. It does. Okay, so as Oliver already introduced me, so no need to repeat myself there. One thing to repeat, though, is the Fast Data Platform. So we launched that, I believe, today or yesterday, depending on time zone. So if things we talk about here today seem interesting to you or seem similar enough, then have a look at the Fast Data Platform. So obviously I'm on the Akka team and the talk's going to be mostly Akka focused, but it's kind of structured for people who are looking to move into this more streaming world, and specifically because of the JDK 9 release this week that happened 2 days ago or so. I also want to frame it a bit around Reactive Streams and what that means for applications and basically the future of integrating systems and pipelines of processing data. So if this is the first time you're looking at Akka at all, it's basically a toolkit composed of very different tools in this toolbox. And today we'll really focus on streams, but there's a lot more than that in the entire toolbox. We have clustering and yeah, lots of distributed systems tooling. But today we'll focus on streams. Some of our customers, but let's dive into the actual meat of the talk. So streams, and specifically in today's talk, the word stream will mean for us that it's a asynchronous, back-pressured, and back-pressure, I'll explain why we actually need that, what that actually means in a second. Element by element processing. So the reason we specify it by saying element by element is, well, if you look at a TCP connection, well, that's also streaming because the protocol is streaming. However, It's really just this infinite stream of bytes, and there isn't a clear designation of where a single message or element ends and begins. And so this is why we talk about element by element processing. So you process an item and then another item, etc., etc. So this is already Akka Streams terminology you see here. We have sources, flows, and sinks, and we have possibly asynchronous boundaries between them. And we'll jump right into basically this back pressure concept. And I'll illustrate that with a more funnier illustration in a second. But the reason we started doing Akka Streams and Reactive Streams was basically that we were seeing a lot of customers doing these ETL pipelines. I don't know, pull data from A, push it to B. And if the target system would it be slower than the source system, like here the source is pretty fast, like 10 messages per second, but the destination is pretty slow, 1 message per second, then you have two kind of scenarios. Or you just start losing data. This is obviously not a fun situation to have. And the other situation, which was more often in at least customers we worked with, was the sinks being overloaded. A sink possibly even being a different system. So what Akka Streams solves here is making this entire pipeline back pressured in the sense of flow controlled. So this entire ETL pipeline you built with such a tool is kind of throttled to the maximum and not faster than actually is survivable by the entire pipeline. And there's going to be cool quotes about that in the talk, about how not only we discovered this problem. And obviously, it's not only linear streams. We can do fan out, fan in. For example, if you have an ETL pipeline, you very often have a system that needs to enrich data or like merge data from different sources. You have a weather service with temperature. You have your own temperature or geographical data about what this area is exposed to, why it's heating up, for example. And then you want to merge them. So we support things like that. All of this is then back pressured and strictly typed as well. So if a thing you've heard about Akka that people would say, ooh, it's not typed, it's not safe to write things, that's actually not correct with Akka Streams, and actually with actors very soon also not true anymore. So that's kind of the streams part of it, but what's the reactive part of it? And reactive is again a term that is very overloaded right now. Partially because for different people it means different things. So if you were to ask a front-end developer what they think about reactive, they would start talking about React or Angular, how it populates the DOM, etc., etc. But there's like a underlying concept to all of this stuff, and specifically back then by our CTO Jonas Bonnier, and a bunch of other people, so Martin Thompson as well, known high-performance guy, was kind of outlined in the Reactive Manifesto. So Reactive really is all of these tenets. It's resilient, it's elastic, responsive, and yeah, it turns out that if your system is message-driven / event-driven, event being a type of event of message, actually, then you can kind of easily achieve this. So message-driven is really the foundation, but what you want to achieve is usually the resiliency or the responsiveness part of the system. Okay, so there's the Reactive Manifesto, and I wrote a mini book about it, like on the previous slide. I linked to it as well because it's freely available from O'Reilly. So, and that's all fun and good. And you have this streaming thing, and you build something with it. Maybe you use Akka Streams, maybe you use RxJava, something like that. But that's a small part of the pie. That's only the yellow piece of the pie, if you will. That's only the reactive apps. Whereas Reactive Systems is really bigger than that. That's where you get the resiliency and actual scalability benefits. So again, to look back to what I kind of taunted at the beginning is the reason we started looking into this flow control and building reactive systems and not only applications. So basically, when I joined back then, the company was called TypeSafe. I joined the team, and we were having a lot of new companies adopting Akka. And well, the new system written in Akka would perform like a boss, handle traffic like a boss. But systems never exist in isolation. So this system would happily handle the traffic, but at the end of the day, you have to hit some other services or some database or something else that maybe wasn't as modernized or just wasn't written to handle such loads. And now, this new system could easily overload the downstream systems, causing it to, well, either out of memory or go really slow. You can imagine. Well, now there's this trend in maybe the last year or so that people will say that I'll just slap a Kafka in there. And we'll get to that. I mean, in the title of this talk, I specifically called out Kafka because I do want to talk about it as the integration kind of layer between services. But it's a bit naive to say that, yeah, we'll just slap a Kafka there and it'll be solved. Because this is something I found this week, basically, 24th September. And I look at the tweet and I'm like, yeah, exactly. So let me quote it. One issue that keeps coming up with Kafka Connect, so that's the system for connecting with databases and importing, exporting, is that many downstream systems don't scale as well as Kafka. Be careful not to DDoS yourself, which is exactly what we were seeing and exposed to like years before that. So it was kind of encouraging that not only we see this problem, but even authors of Kafka books have the exact same problem in the field. So if only there was a way we could solve that problem. And yeah, here I'm kind of hinting at it already. This is exactly what the Alpakka ecosystem is. But before we get to Alpakka, which is our nifty little code name for an ecosystem of Akka Streams connectors, let's jump back to Reactive Streams. So we talked about what it's addressing. It's addressing this asynchronous, non-blocking, back-pressured processing of elements. And it's a standard that we led and co-developed with people from Pivotal, Red Hat, and Oracle, obviously, and other people who just joined the community there. So this was in development for, well, since 2014, like early 14 or late 13, if you will. And why am I talking about it? Because I spent most of my time there working on the TCK. So the TCK, that's a technology compatibility kit, and it allows you to check if you're actually abiding to the rules that the Reactive Streams kind of demand from you. And yeah, this week, this has been included in JDK 9. So from this day on, this shall not be known as Reactive Streams, but as Java util concurrent flow. And inside there, there's interfaces like publisher, subscriber, and subscription. So whenever someone talks to you about, yeah, what's new in JDK 9, you can tell them, hey, Reactive Streams have been merged. So it is exactly Reactive Streams. Some people are sometimes confused. Is it like inspired by or similar or something like that? No, it's a one-to-one copy, and it can be verified using the TCK that we did there in the open and Reactive Streams. So we talked about how it's integrating over asynchronous boundaries, but why would we want this library which doesn't even have implementations, right? It's only interfaces. So what the JDK now contains is only interfaces and not even implementations thereof. So the reason we really wanted to have that is to have various Reactive Streams libraries, be it, I don't know, RxJava or anything else, or Akka Streams, obviously. And all these libraries can talk to each other and still respect this back pressure, this flow control, this safety guarantee that you get from it. And it's still a fully streaming API. So this is how it looks. I used previously this picture that soon, but now it's actually now. And now the tricky thing is, okay, the JDK contains these very simple interfaces, but the rules to implement them are actually very difficult. So if only there was some toolkit out there that's goal was to make concurrent and distributed apps simple. Well, that is exactly Akka. So the entire purpose of having these interfaces in the JDK and in relation to what that means for the entire ecosystem, like the ETL ecosystem, is that now you actually don't care if people implemented the thing using some library or the other library. You can just connect your pipelines together. So this is a huge and kind of invisible win for the ecosystem. So I really wanted to build up and kind of explain why this is so important. Protocol-wise, it's a batch pull asynchronous flow control mechanism. We talked about this already. And yeah, Akka already supports it. So we have merged support for it. Had to figure out a bit on the dependency sides, how to solve that nicely. But we were expecting to release a Akka Streams version basically this week, maybe tomorrow or the day after, that will support JDK 9 already. So, Akka Streams. And as everything, we always do complete Java and Scala DSLs. Also important to note, maybe more during the early days of our company, but people would always think that, oh yeah, it's the Scala company, they don't care about the Java API, they just slap it on. That's actually not correct. We spend a lot of time on making sure the Java API is both nice to use and feels whatever is natural to a Java developer in a given scenario. So the two DSLs are separate and fine-tuned to whichever you would be using in a given language. So for example, this is how the API looks like. So we have sources, flows, and sinks. You kind of should have be able to guess the meanings of those already. So a source can only output data, a flow can accept and emit data, so it's like a transformation function, and a sink only accepts data. So already here you can see that sink for each, it can emit a completion stage of done. So that basically means that completion stage will complete whenever the stream has completed, right? Makes sense. And as a Java developer, I'm expecting a completion stage or a completable future there, right? But as a Scala developer, I would use a Scala feature. So again, all of the types are completely separated and you get what exactly you would be expecting given your favorite language. Of course, lambdas work in Java as well, so you get a nice map like here. So to map it to types, basically again, visual representation of what we talked about, inputs and outputs. And we do have more complex shapes, and you can have an arbitrary shape as well. For example, if you want to merge two data streams or three data streams and emit one data stream, that's also very easily doable. So now looping back to Alpakka and what this actually means to, again, ETL. So because we have these shapes, we have these flows and sayings, and they're kind of opaque. From the toolkit's perspective and, well, the developer's perspective as well, you don't really care what the building block is doing as long as it has the right type, right? So if it's a source of person, you really don't care if it's from a database or if it's from a TCP connection or HTTP or an HTTP client call or just from a file on disk. You really don't care as long as it's the right type, so person. And now imagine you have a small library of stuff that can work with specific shapes. And this is basically the Alpakka ecosystem, what we aim to develop here. You have some things that are prepared and some things that you can build and fit for existing shapes. And now the interesting bit is you can also compose them by hiding stuff, right? So here we have a lot of blocks on the left side. We can just compose a big block out of that, which would be just two sources. And well, if you give it two sinks, the thing can run. So by really using this type safety and compositionality, we can build a nice ecosystem that instead of forcing everyone to map between things and implement pulling from FTP 50,000 times, we just write it once. and then you can connect with whatever you want. Obviously, sources and sinks, that's Akka type, Akka Streams types, so that connects with Akka Streams. But because Akka Streams implements Reactive Streams, there's completely zero lock-in, and if you want, you can use any other library to consume or to emit into it. So that's also kind of a specific design goal, that we know that these systems linger around. They're not picked up until something has to be fixed in them. And we really want to make sure that if you write in an Akka Streams, you can always pick it up later, like 2 years, in 2 years, in 3 years, in 5 years. That's why the zero lock-in idea that we have here. So, for example, if you have this flow on the left side, you're like a transformation function, you're pulling something from Kafka and you transform it into some acknowledgements to Kafka, for example. But the same shape can be emitted, well, emulated as a source of stuff, maybe just sending some test data, and a sink that just acknowledges these things. So there's a lot of kind of mind-bending compositionality going on there. So to focus on Alpakka a bit more, so like I said, we announced that basically a year ago, and it's a community for stream connectors. As I said, we kind of don't judge, and it's very inclusive in that sense, but they're usually implemented using Akka Streams. This is a short list of things we have already, and when we say external, we still kind of count this as the Alpakka ecosystem. For example, the Kafka here on the right side, that's Reactive Kafka, that's a library we maintain. So it's a Reactive Streams connector to Kafka, and I'll show an example of it. And Eventuate and Camel, that's again implementations done by basically the Akka community as a large, Martin Krasov specifically. So this entire thing we refer to as the Alpakka community. And we happily list external projects on the page as well. And existing in Alpakka, that just means that these exist in this common shared repository, kind of like Camel exists, and it has a huge list of connectors, right? So this is the same what we're achieving in Alpakka. So when I first did a talk about Alpakka, we were at 0.5. I think this must have been half a year ago or something like that. And yeah, the list is kind of interesting. There's some HBase, MQTT, Cassandra, that's good and useful. We had Kafka already, but when I looked today at the integrations we have, I had to scale down the text and it wouldn't fit anyway, so I had to put this on the right-hand side list of stuff because the community has really picked up, as you can see. So we have a lot of connectors to the AWS services, and now also interestingly, and because of a partnership with IBM, we have some connectors to, and now a positive surprise, because you may think that, oh yeah, it's going to be connectors to some proprietary IBM stuff. While that's not exactly true. What that collaboration entailed was a better support for the S3 protocol, better support for JDBC things, which, yeah, of course, by the way, you can use these APIs to hit IBM stuff, like databases or their S3 compatible APIs. But again, it's this idea of sharing connectors, and that you can use this connector to hit maybe an IBM thing, maybe the actual S3, or anything else, like the Google pub-subs, etc. So again, all of this is possible because we have these shapes that we extrapolate into these generic ideas. So how does an end-to-end kind of work day with Alpakka look like nowadays? In my example, let's say you just want to have like a monitoring service where you just pipe stuff out of Kafka. Because we talked about Kafka, let's use that as an example. And you just want to do a JSON streaming thing. That's a trendy topic as well, and Akka HTTP being something I worked on close to my heart. So the first thing you would do is you just skim the Alpakka website. At the bottom there, I linked to the Akka Stream Kafka, so that's Reactive Kafka website. And yeah, seems I didn't link to Alpakka. I'll link in some other slide, I think. So you go to the Alpakka website, you look at what's interesting to you. Let's say Kafka. So you click the Kafka thing, you know the Kafka dependency, you import it, you import the dependencies from Akka HTTP. Then basically you pick which kind of source you want, right? You would do that by looking at the Alpakka documentation or just for source code. In this case, I just wanted to list that we have several different styles of API in Kafka. So you can have a plain source, that's the easiest to consume, it just gives you the record. Or you can have a committable source that gives you a committable message, so you have control over when you want to commit the thing. And a few other ones, like when you want to have a source per Kafka petition and more advanced patterns like that. So again, you pick whichever you want, you get the source, then basically you connect that source to some kind of sink and you're done. So here specifically, that's an Akka HTTP route. So the path streaming, we complete that with measurements. And I hid the code a bit too much here. Yeah, so basically the measurements would have been a source of strings from the Kafka consumer, and the consumer settings carry the type and the deserialization, right? So this would be properly typed and properly deserialized in runtime. And then you profit. As easy as that. But again, that's nice and easy, but that's still kind of sticking to one library, one ecosystem. But what if you want to use a different source? And this is kind of where the powerful thing starts to happen, is where you can just pick any kind of source you want, and as long as the type fits. So for example, yeah, let's go files on an FTP server. I actually remember one of my ETL jobs was exactly that, just walking FTP servers and looking for files to import and then importing them. And it was pretty boring code to write, all of this FTP walking and reconnecting and streaming the data out. So it wasn't pretty. And nowadays with Alpakka, you can basically say, okay, walk the FTP recursively for every file. Yeah, stream that file for me. This will be actual streaming, and with a breadth of at most 3 files being streamed at the same time. You can configure that here. And then again, you just connect it and profit. So that's the general idea we have with Alpakka and the ecosystem. So it's about the long-term maintainability and also this exchangeability of the types. It also helps with testing. If you imagine that, okay, I did it with my Kafka thingy, but in tests, I don't really want to start a real Kafka. You can just have a mock Kafka. You can start an entire thing like that, but maybe you can just swap this source for a source single, my specific consumer record, and start it like that. So again, very good for testability, because you detach whichever source there really is by this source type. So what, when, and why? This is a question we always got in every single previous webinar we did, so I figured let's take my colleague's slides. Thanks, Johan, who really modeled it very nicely in this diagram. And it's about when to use actors, when to use streams, when to use futures, things like that. So on one hand, we have complexity on the y-axis, and the x-axis is kind of modeling power, the things you can express using this API. And on the left-hand side, there's futures. If you think about futures, nowadays Java as well, so completion stage, completable future, and Scala futures, they're very simple to use, so pretty low on that side, but also very limited. Very limited in the sense of they cannot be distributed. I'm sorry. There's no such thing as a distributed future that silently scales over multiple servers if one goes down, etc., etc. It just doesn't make sense to abstract this thing like that. So it's very simple, but surprisingly, it gets a lot of stuff done. So by the rules of least power, biggest bang for the buck, futures are pretty good. Then streams are a bit more complex because you need to think about life cycle, right? A future has a super boring life cycle. It only is either completed or it's completed with a failure or the actual value. Very simple. A stream, on the other hand, well, it's going to stay alive for a while. Then during the lifetime, it can complete or fail. And then, well, was that okay? Do you want to resume it, etc., etc.? It's a bit more complex to think about life cycle of streams. We have some operators that help with that, like recover, retry with delay, restarts of an entire stream, things like that. But a bit more complex, but way more useful because you can model actual streaming services with that. A future wouldn't be good. Next, we have actors. So the reason actors are more complex is, well, they model a more complex domain, which is any kind of generically expressed concurrency. So that's quite difficult domain, plus they can be distributed. On the other hand, we also make it quite simple. I mean, if you think about what you would have to do to transparently, and we're thinking, figure out the actor, if you want to process something locally or remotely because, oh, this machine has already a lot of used CPU, better process it somewhere else. If you have questions like that, that's basically actors. They can transparently scale out, find the right node to process your data and process it there. It's very much like a service mesh or yeah, a cluster, basically cluster. Now, actors have long been kind of laughed at, well, not by the airline community where kind of actors were inspired from, but because they're untyped as well, but by maybe the Scala community, that actors are indeed. So we finally moved to address that. And I have a full talk about how this is an actual pretty difficult computer science problem to really solve that. But we think we finally nailed that. And we have a preview available of Akka typed. So that's typed actors. And again, here I draw the dot a bit lower because when you have types, it's easier to reason about things. And yeah, if you're kind of in the past looked at actors and you were thinking, yeah, I still would want the types there, then this is the best of both worlds. So it's less complex because you have types, but you can do all kinds of distributed computing on them. And lastly, I did want to put that here. So threads and logs. Yes, there's no good reason in this day and age for application level developers to touch them explicitly. So don't. And also non-reactive things, just don't touch them. It's a waste of CPU, it's a waste of resources, it's a waste of your time to figure out how to make a working system when everything blocks and starts failing. So another question we often got is, are streams replacing actors? No, that's absolutely not the case. They have very separate use cases. So in ETL pipelines, what usually would happen is such a pipeline can be seen as a job, right? And when you think about batch processing terms, you'd call such a pipeline a job. And what happens if the job fails? Well, do you want to restart it? Do you want to back off a minute and then start it again? Or maybe it failed because it was CPU starved. You want to start it somewhere else on a different node. So they encapsulate state. They are mobile, as in they can be located on different servers and dynamically just by cluster sharding. So an actor is a perfect kind of host or supervisor for such a job or processing pipeline. And then inside of that, you have your pipeline which pushes data from A to B. There's a great post about that by a community person, Colin Breck. Look him up, great post, and just a great series of posts, actually. So yeah, in practice, this would look like this. So you have your local abstractions and then connect them with cluster sharding, for example. So, because usually I went way over time in these talks, this one is a bit shorter. So let's jump into roadmap update, and then let's do a short Q&A session. So whichever questions you may have, feel free to type them. I think first like a small window where you can type questions in the webinar thing, and then we'll get to them. So roadmap update. So the upcoming months will be mostly about stabilizing stuff. So we have the new Akka remoting, which is a basically 10x improvement over the previous remoting. We have been able to break 1 million messages per second with it. It's based on an error, so obviously Akka Streams scale to, well, actually tens of millions locally, and in the distributed setting, again, kind of like for remoting. In Alpakka, we have still a growing community. Basically, a lot of things to merge because the community is really active in providing pull requests. And the IBM initiative is again helping us, and there's some people helping again with providing more connectors there. So that's pretty exciting. Yeah, Reactive Kafka, still maintaining. Akka typed last week. Last week we provided a cluster API for Akka typed, a persistence API preview for Akka typed, and a Akka Streams integration for Akka typed, which this isn't merged yet, but very close to. So basically, the entire ecosystem of actors is slowly moving to Akka types. It's currently not stable. Oh yeah, to explain. When I say stable, we don't mean that something is unstable or unusable. When we say stable, we mean API freeze, right? So currently, API may change a bit. So if you're curious, have a look, and would be a great time to give some feedback. Also, we're done with most of HTTP2 work, so HTTP supports that, and is powering Play by default since the latest version. So again, we have a lot of consolidation in the Lightbend ecosystem here. So this isn't really an announcement because it was very publicly available on like GitHub and our sprint plans, but yes, there's multi-data center support coming for Akka. So if that's something you're interested in, specifically, we have some active things. Feel free to email me or Oliver, get you some more information about that. So no date about that yet, but we're working on it. Last and not least, some of the commercial things. I picked some of the commercial things I'm excited about. So that's this thing, which we have right now. It works across Akka HTTP, Akka remoting, and Scala Futures. Integrates with Jaeger and Zipkin, as well as just general metrics and monitoring. Those actually work as well with Akka HTTP as actors, and a little bit, as I said, Akka HTTP is now under the engine powering the Play framework, so Play gets some basic metrics out of that, but we're going to be working on making that really native and first class, so you get the Play roots to properly show up. Now, the interesting bit here to connect that to this topic of today's talk is, okay, so how do we connect, let's say you got a request and that request started off a job or a processing pipeline somewhere. Can we figure out which requests triggered that? And yeah, in a way we can. We cannot trace through Akka Streams yet, but it's coming very soon, I think. So, is this stuff ready to adopt in production? Absolutely. And that's a fun quote I heard on the JDK adopting Reactive Streams isn't the best long-term endorsement, blah, 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 then I don't know what is, right? Basically, this entire ecosystem of integrating and processing in a streaming fashion, that's not going away. And we've already seen APIs like the new API from Amazon Web Services they announced that the new SDK will be using Reactive Streams, which exactly means they will be using the JDK 9 interfaces once they can require JDK 9, right? So basically, all of these ecosystems are converging on this streaming types there. So super exciting. Yeah, if you want to read more, there's 2 resources other than the documentation, because documentation I hopefully think most of you know about. It's just akka.io/docs. And then we have a blog. The blog but more kind of guiding. Our documentation is more on the side of a reference documentation. So if you were to do X, this is how. This is more of a blog style. So if you're interested in more of guide styles, the developer Lightbend site, we launched it recently, of tutorials or guides, if you will, about Akka. So have a look. I promised both links to the book I wrote about just why reactive, what means, the components of it, what are the confusions, etc. So that's the bit.ly link, bit.ly why reactive. It's freely available. I think you have to click through like be logged into O'Reilly, but it's free. 12 pages or so, not a very long read. And if you want sources from today's, actually there's a lot more sources for integrating Alpakka with different things. Then check out this repository. If you want to contact us, contact Oliver, or you can contact me here. So with that, we have some time for questions.
All right, thanks so much, Konrad. I'm just about to put those links into the doc, into the chat for everybody, so that they could actually go to them now.
Yeah.
And we do have quite a few questions. One of them is coming from our friend Dominic Dorn, who would like to know what it takes to integrate Akka Streams with Alpakka and Play framework while signaling back pressure in Play, rather propagating back pressure to what Play does.
That has a bunch of answers depending on which level. If you talk about HTTP entities, that just works. It just works. You can respond with a source and it should just work. They also have these iterate style thingies, but I think those are deprecated. But we do provide a bridge that whenever you do an entity, that's basically transformed to a Akka Stream source, just works. The WebSocket API they provide, I think, does not make it simple to abide to back pressure. And which other API could you be thinking about? I think that's the main ones. I think only the WebSocket API in Play is a bit tricky to get right. I would have to check that. I haven't been working on that one. But in general, it's pretty much end-to-end. As long as you can provide someone a source or a sink, things just work.
Mm-hmm. I think that was the whole point of Alpakka.
Yeah, exactly.
So there's a question about Akka Streams and basically latency. And the question is, are there use cases where it makes sense to use Akka Streams for ETL with sub 100 millisecond response time?
Yeah, absolutely. So sub 100 millisecond. Oh, so I'm trying to remember the numbers we have for materialization time, but at most it's around 10 is like the worst you'll get for materialization. So we have 2 steps in Akka Streams. And a thing to remember is when you start a stream, that's the materialization part. And that's maybe 10 millis or something like that. But when you talk about the actual element processing, when we talk below millisecond, it's basically method calls. Well, it goes through queues, but super fast. So you can design it such that you can keep a stream alive, and then you don't even pay this 10 millisecond cost. Then it's just below millisecond things.
Okay, great. There's a question about monitoring. And I know that you've spent a lot of time working out with our telemetry team and so on. The question is, how can you monitor the number of process items throughput in a flow without impacting the performance throughput of the flow itself?
Yeah, so actually streams monitoring is sadly something we have not shipped yet. We worked quite a bit on it, and well, throughput is one thing to measure, and we can certainly do that, but basically the answer is we'd do that for you, don't worry. But what I want to add here is just throughput is not is a bit counterintuitive in Reactive Streams, because the entire design of Reactive Streams and any Reactive Streams library, be it Akka Streams or RxJava, whatever, is that they will slow you down to the point where they're safe, right? And in other APIs, which wouldn't do that, you'd be happily measuring some super throughput, but then the thing would crash in production. So we wanted to find some metric that would kind of show, is it healthy or is it not healthy, rather than the throughput. But yeah, absolutely, we'll do throughput measurements. It's just not out yet.
Okay. There's a question about and Alpakka and whether connector for both sources and sinks.
Yeah, it's on a case-by-case basis. So if you go to the Alpakka website, just Google for Akka Alpakka, and then on the left-hand side you have, well, the word will be connector, right? But if you go to this, to each of those, usually it's going to be both a source and a sink. Some of them are actually exposed as a flow. Both are, for example, if you pipe data into Kafka, what it responds with is acknowledgements that it has taken the write. So the shape of what we expose is kind of dependent on the data source that it is. So for FTP, for example, we have only sources. I don't think we have a sink for FTP yet. But if you have a specific one that you miss, please open a ticket on the Alpakka issue tracker, and hopefully we'll get to it.
That's the best you can. That's the best we can hope for, I think. The last question we have is about volume constraints with Akka Streams, and you did mention Akka remoting and using Aaron and so on. But does Akka Streams handle large volumes of data well for ETL? Yeah,
so because of this back-pressured nature of it, when you say big volume, right, you basically mean, yeah, I don't want to load it in memory and blow up. So that's exactly what it does. What we do is between the stages we have a set buffer space, and you can configure that to be smaller or bigger, and we'll just never load more than we actually can load. And if you have situations that, well, one node can't actually handle this, then you can always spread the processing out to multiple nodes. And that would be using actors fun. So absolutely.
All right, great. Well, thank you so much for joining us today, Konrad. Folks, that's all the time we have. Yeah, if you do have any further questions and you are a Lightbend subscriber, as I mentioned, you can ask all of your what-ifs, how-tos, and best practices advice directly to our engineering team, including Konrad, through the customer portal. And you can email me directly at oliver@lightbend.com, and I'll do my best to find the right people for you to talk to. Again, Konrad, thanks so much for joining us today.
Yeah, thank you.
And have a lovely evening in Tokyo.
Yeah, thanks. See ya.
All right. Thanks for joining us, everybody. Have a wonderful day. Bye-bye.